Let's begin real algebra, translating word problems into math and solving them, because algebra is a really effective tool at figuring out how to solve some of these complicated problems. Let's begin. We'll do much of this together. There are three that you will work on your own. I'm getting you started on all three. So there's not a whole lot left after this lesson, though it may take you some time to think about it and work through the answer. Much of the work has already been done. Anyhow, let's look at problem number 1. Jim has 14 CDs, which is 5 more than 3 times as many CDs as Anna has. Use X to represent how many CDs Anna has. Write an equation and then solve it to find out how many CDs Anna has. That's a mouthful. So, let's first figure out what we have. First, we have an exact number of CDs that Jim has. He has 14 CDs. We know that. After that, it gives a description of that CDs, of that number, comparing it to Anna. 5 more than 3 times as many CDs as Anna. I hate as many as, that's so wordy. 5 more than 3 times the CDs Anna has. So, what that tells us, just putting it in a very simplified word form, we have the exact amount Jim has, and then we have the description of the amount he has. It's 5 more than 3 times as many as Anna has. Now, it's really important. This page does not have you do this. I want you to do this. In fact, I did it on every one of them, including the ones you're doing by yourself. You've got to always define the variable. That is extremely important. You always do this. Always define the variable. And it tells you exactly what it represents. Use X to represent how many CDs Anna has. So I wrote X, number of CDs Anna has. It's really important that you define that. Most of the time, your word problems are not going to spell it out like this, but we're just getting into it. Most of the times, you've got to figure it out yourself. I want you to be in the habit of always writing that. Anyhow, so now, this is the simplified word model. Now, I've explained what the X means. Now we're translating it into math. The exact amount Jim has, 14, equals the description. That's 5 plus 3x. It's 5 more than 3 times Anna's. X is the number of Anna's. So that is our equation that goes with this word problem. Suddenly, it doesn't seem nearly as complicated. That was a mouthful. My head was spinning, but now it suddenly seems more manageable, and I can wrap my brain around what it's saying. That's the amount he has, and that's the description of the amount he has, including compared to Anna's. Now I'm going to come over here and solve it. So this right here, I'm rewriting it here. Then the first step, because you want to get the variable term by itself, is to subtract the 5. Once you do that, you're left with 9 equals 3x. From here, we'll finish it out. I'm not going to look. Now, to isolate the variable, you'll divide both sides by 3. Sorry, I'm writing in an awkward way. So, x equals 3. That means that Anna has 3 CDs. And if you plug that x in here and figure it out, you would see that 14 is 5 more than 3 times 3. So Anna has 3 CDs. You don't have to write the answer in a complete sentence like that, but I would at least like you to say, 3 CDs. Make sure you label your answer. What does that 3 represent? CDs. It's 3 CDs. All right, let's look down at problem number 2. This is one you'll do by yourself. Don't worry, we'll go through a whole lot more examples before you're stuck doing this on your own. But I've done 2 parts of it already for you, and you'll just have to do the translation and solve it. Alex worked on his math homework for 25 minutes, which is 5 minutes less than twice as long as Becky worked on hers. Use H to represent how many minutes Becky worked on homework. Write an equation and then solve it to find out how many minutes Becky worked on homework. Okay, so we want to find out how many minutes Becky worked. We know exactly how many minutes Alex worked. So the first thing we have is exactly how many minutes he worked. And then we've got a description that compares to Becky. And using the minutes he worked and the description, we'll be able to figure out how many minutes Becky worked. So the word model, exact amount he did homework, equals the description. And when you're writing his description, it includes how it relates to Becky. H is the number of minutes Becky worked. That seems like it should be an M for minutes. H seems like it would be for hours. That's weird. So when you write your equation, the only thing that goes first is the exact amount Alex worked. How many minutes? You write that number, equals. And then you're going to write how it compares to Becky's hours, minutes. That H is throwing me, how it compares to Becky's minutes. But don't worry if you kind of get it, but you're like, no, I can't do that. No. Because we still have more examples we're going to do. Look at number 3. Ben has $400. He gets paid $15 to mow each lawn. He would like to get a new TV that costs $1,250. Use M to represent how many lawns Ben mows. Write an inequality to solve to find out how many lawns Ben must mow to have enough money. You see how you read that and you're like, that is so complicated. There is no way I can figure that out. It is amazing how just taking that information, this is what I do as an adult. I can take that information and just write it out, what it's telling me, and then translate it to math, and then I can find the answer. It's really neat. So here we go. The model. So we know he needs to earn at least $1,250. So we've got to figure out how he's going to get there. He already has some money, and then he's got to earn some money, and that needs to be at least $1,200. So he has money. We know how much he has. We're going to figure out how much he needs to earn to have at least $1,250. Got it? Now it seems a little more understandable. So I went ahead and did the M is for lawns that Ben mows. So when you see M in the equation, that will be lawns, the number of lawns. Now I'm going to move this down here. There. All right, we'll get this figured out. I want you to focus on one piece of information at a time. Now, look carefully. He has $400. What does he already have? He already has $400. The money that he needs to earn. So we're going to add the money that he needs to earn. He gets paid $15 per lawn. For every lawn, he gets $15. So he has $400. We're going to add $15 per lawn, and we need to have at least $1,250. You see how that works? Now I can solve it. We set it up. And remember, it's an inequality, but you solve it the same way you would solve an equation. So the first step is to isolate the variable term. We want to get rid of that 400, so we'll subtract 400 from each side. When we do, that cancels out, and we're left with 15m is greater than, is greater than or equal to, well, that didn't work either. 850. Now we need to isolate just the m. So we'll divide both sides by 15. When we do, 15 cancels out. M is greater than or equal to, I don't want to do the work, 57. 850 divided by 15 is 57. M is greater than or equal to 57. So the answer is Ben must mow at least 57 lawns. If you could put something like at least 57 lawns. It says, write an inequality and solve it to find out how many lawns Ben must mow to have enough money. At least 57 lawns. On to number 4. I covered up everything so we can better focus on just the problem itself. Gwen has $50 to spend at the video store. She can rent a game system for $15 and video games for $4 each. Use V to represent the number of video games. Write an inequality and solve it to find out how many video games she can rent. How many video games she can rent? I just noticed that. All right, so all those times that kids can't find their mistake and then they ask me for help, and then while they're reading it to me they say, oh, I found it. Same sort of thing. When you're reading something to someone else, suddenly mistakes are blaring. Anyhow, I didn't make this. Someone else did. Not my mistake, but I cut it. So I'm not always the mistake maker. Sometimes I'm the mistake catcher. So she's going to the video game store. She wants some video games, but she doesn't have a system. So the first thing she has to do is she's got to rent the system. So that's going to be $15. So we know she's got $50 to spend. 50 of that is going to go to the system. And then she wants to rent as many games as she can for $4 each. So we're going to write this to find out how much money she can spend, how many video games she can get, and still be under $50. It'll definitely be an inequality because it doesn't have to be an exact amount just as long as it is $50 or less. Let's start with looking at the word model. First, we have the single item amount. That's going to be the game system. She's got the game system, which is, we know how much that is. We've got a single amount. Plus, money for the other items, all the video games that she's renting. So we've got the one item plus the other items. We don't know how many she can get, but we're going to find out. That has to be no more than the money she has. When you go to the store, you have a certain amount of money. They're not going to let you buy more. They're going to let you only buy as much stuff as you can pay for. So she wants to see how many video games can I rent with $50. But we've got to make sure that we know she's got that first $15 goes toward the system. As it said, V represents the number of video games. V is appropriate, video games. So let's translate this into math. The amount of the video game system is $15. We know that's $15. She's only going to get one, so that's simple. $15 plus the video games. However many video games she can rent has to be less than or equal to $50. $15 plus $4 for every video game must be less than or equal to $50. So 4 times V, because to find out how much she spends on video games, you're going to charge $4 for every video game, 4 times the video games. Does that make sense? Yeah, I know you're not going to answer me at this moment. You'll probably not even answer me while you're watching unless you're just like, dude, I'm so confused. video game system plus all the video games is less than or equal to 50. Now we'll solve it. We already, what am I saying? Let's isolate the variable term first. So we'll subtract 15 from both sides. That cancels out, so we have 4v is less than or equal to 35. 50 minus 15 is 35. Now let's see, 4v is less than or equal to 35. I want to get the v by itself. So I'm going to do the opposite and divide both sides by 4. That cancels out, and I'm left with v. I'm going to come over here. V equals, or is less than or equal to 35/4. Oh my, okay, so 4 goes into 35 8 times with 32, 3/4 left over. Okay, that's interesting. So she can get less than or equal to 8 3/4 games. Can you rent 3/4 of a game? No, you can only rent a solid number of games. So it's got to be less than or equal to 8 3/4. 9 is more than 8 3/4. It's got to be less than. So the most video games she can buy for $50 or less is going to be 8. 9 would be too much. 8 is the most she can buy. At most, 8 video games. There you go. So the most she can buy is 8 video games. All right, number 5. Tom's son is 34 inches tall. To ride on the go-karts, he must be taller than the line posted on the sign. The line is at 4 feet. If Tom's son grows 3 inches each year and we use y to represent the number of years, write and solve an inequality to find out how long until he can ride the go-karts. Oh, that's a mouthful, isn't it? Let me cover this up so it's not distracting. Oh my, okay, so he's not tall enough to ride the go-karts. Now this is in inches, so we're going to use inches instead of feet. So anytime we refer to how tall he's got to be, we're just going to use 48 inches because you can't go from inches to feet. That wouldn't work. So inches, inches. Anyhow, so we're going to start with how tall he is. We're going to add his growth per year, and then we'll have how tall he's got to be. Let's look at this first one. We'll start with his height now. Then we'll add his growth, and that's got to be at least 48 inches. Y is the number of years. The reason that we need to know the number of years is because it tells us his growth rate. He grows 3 inches a year. So now let's see how this is translated. 34, he is 34 inches tall, plus 3 inches of growth per year, 3 times y, is got to be at least greater than or equal to 48. Height now plus growth per year is greater than or equal to the growth he needs to be, the height he needs to be. Now we can solve this. Let's see, we're going to isolate the variable term by subtracting 34 from both sides. We have 3y is greater than or equal to 14. I can tell we will not have a whole number, but you can't rent part of a video game, but you can have part of a year. So it's okay for this to not be a whole number. When solving equations, you're going to encounter things where you've got to make the decision what's realistic. And you could have put, on the one above, you could have put 8 3/4, and that would have been right. But when you went to the store to actually buy the video games, if you said, I can buy 8 3/4 video games with my $50, the guy's going to say, oh, well, since I can't give you 3/4 of a video game, I guess I'll let you rent 8 video games. You see what I mean? All right, so now we will isolate just the y by dividing both sides by 3. Y equals, 3 goes into 14, 3 times 4 is 12, 4 2/3. So he would need to wait at least 4 2/3 years. I hope he's not wanting to ride that soon, because it's going to be a while. Let's look at problem number 2 one more time. I bet it'll mean a little bit more. You start with the exact number of minutes he reads, and that equals to the amount of minutes he reads compared to Becky's. So when you translate that, the exact number of minutes equals his description compared to Becky. And that's how you'll figure out how many minutes Becky worked. Number 6 and 8, both of those you are going to do on your own. I'm going to get you started on both of them. Number 7 we'll do entirely together. Number 6, Jessica ate 24 cookies as her afternoon snack, which is 2 more than twice as many cookies as Dana ate. Use C to represent how many cookies Dana ate. That makes sense. Write and solve an equation to find out how many cookies Dana ate. So, we know exactly how many cookies Jessica ate. We know her exact amount. And that is the same as her amount compared to Jessica's. So when you write it out, you'll put her exact amount equals the description compared to Dana's. And that will tell you how many cookies Dana ate. Problem number 7. Jim earns $9 an hour cleaning houses. So it's going to be 9H, $9 per hour. You already know that, $9 per hour cleaning houses. You know what? I'm glad I guessed right, H for hour. That time it makes sense. He wants to save $900 for a new stereo system. So far, he has $490. Use H to represent the number of hours he must work. Write and solve the inequality to find out how many hours he must have to earn enough money. So, he earns this per hour. He wants to save this. He has this. We want to find out how many hours he must work. Let's examine how we can put this in a word model to organize the information that we have. We start with the money saved. He's already saved some money. Then we're going to add the money he earns. And that will be that has to be at least the money needed. Because he wants the stereo system. See, these are real life scenarios that you will in real life encounter. And this is a great way to figure it out. So H stands for the number of hours Jim must work. Now I'm going to translate this into math. He has $490 already. He's going to earn $9 per hour to get at least $900. So the money he has plus the money he earns, the money he needs. And it's $9 per hour, so that's how you know it's 9 times H. All right, so now I'm going to set this up over here to solve it. 490 plus 9H is greater than or equal to $900. To isolate the variable term, we will subtract 490 from both sides. Cancels out. We have 9H is greater than or equal to $410. I did that in my head. You may, if you get a problem like this yourself, you'll have to regroup. But anyhow, so now let's think about this. Yeah, 9 does not go evenly into that amount. Remember, you could not have you couldn't rent part of a video game. Can you work part of an hour? Of course you can work part of an hour. So it's okay that this one will be a fraction. We will divide both sides by 9. Then we have H is greater than or equal to, let's see, 9 goes into 41, 36, 4 times. 36, 37, 38, 39, 40. With 5 left over, we've got 50. 9 goes into 50 5 times, because it goes into 45, with 5 left over, and 5 ninths. Now, I'm doing this in my head because I'm trying to do it fast. Now, if you can't do that in your head, which I don't think I could have done that in my head in middle school or high school. If you can't do that in your head, then write a long division. In fact, I think that you probably should. I would have needed to. Remember, I'm a math teacher. I do numbers all the time. I've got numbers going out my armpits, if that's possible. I can think about this. All right, so he needs to work at least 45 and 5 ninths of an hour. So how many hours he must work? He must work at least 45 and 5 ninths hours. That's going to be a hard-earned stereo system. Finally, number 8. You'll do this one by yourself. None of the ones you're doing are inequalities. And I think the ones that I'm having you do by yourself are more straightforward. I want to focus on just getting you to get comfortable changing that to that without having anything overly complex. The ones that are more complex, I did with you. So relax your mind if you were like, oh man, some of these are really hard. Don't worry, the ones that you're doing are not as complicated. They're more straightforward, I think, and I feel like I know actually that you can do these. Susan makes $30,000 a year, which is $5,000 less than half of what Mary makes a year. Use K to represent how much Mary makes per year. Write and solve an equation to find out how much money Mary makes each year. So what we need to know is she makes $30,000 a year, so we know exactly how much Susan makes. Now it's going to describe her amount compared to Mary. $5,000 less than half of what Mary makes a year. You see the word is? That's how you need to know that's how you know there's an equal sign. Susan makes $30,000 a year, which equals $50,000 less than half of what Mary makes a year. Now, I would not be able to solve this without algebra. I couldn't just sit here in my head and think, oh, yeah, I know, and figure it out. I need to set it up as an algebraic equation, and then it's easy. All this time you thought, why do we do algebra? We're never going to use this. There's no A's and B's and X's in real life. Well, guess what? There really is a reason you'll use this. Let's see how we can organize this into a word model from which you can more easily translate it into math. We'll do the word model. I want you to write this down. Make sure that you write down everything that I wrote down in the 3 problems that you're finishing on your own. The word model. So this is how we're setting it up. We're starting with Susan's exact amount. And that is, and then a description of her amount compared to Susan's. Or compared to Mary's. A description of her amount compared to Mary's. K is the money that Mary makes per year. So when you set it up, Susan's exact amount is equals, and then describe it compared to Mary's, and solve it, and then you'll know how much Mary earns. I think that you'll be really proud of yourself in how you can figure out these complicated word problems just by setting it up with algebra. Isn't that cool?